A molecule has electron domains and lone pairs. An electron domain is when two atoms form a covalent bond with each other and have a bonding pair of electrons. A lone pair, on the other hand, is when there's a pair of electrons on any atom and that doesn't bond with any other electrons. Western model takes in these two kinds of domains and arranges them based on minimal electron repulsion. Lone pairs have more electron repulsion than electron domains. Furthermore, electron domain geometry describes electron domains around the central atom. Using electron domain geometry, the Western model, and even Lewis structures, we can effectively draw a molecular geometry. The diagram on the left depicts a molecule with a trigonal planar geometry. It has evenly spaced out 120-degree bond angles in atoms to reduce electron repulsion. However, the diagram at the right has a lone pair of electrons that exerts an electron repulsion that pushes away the other two bonds. This creates a bond angle that is less than 120 degrees.
Thanks, Anvith. So next we're going to be talking about drawing Lewis structures. And when we're drawing Lewis structures, there are 6 general steps. So the first of these is determining the central atom, and we do this based off of electronegativity. So the least electronegative atom goes in the center, and because on the periodic table carbon is less electronegative than chlorine, we know that carbon is the central atom. And after determining the central atom, we have to find the total number of valence electrons. So in the periodic table, we know that chlorine has 7 valence electrons and carbon has 4. And when determining the total number of valence electrons, we find that there are 32 total valence electrons. And after that, we determine the number of bonds. So when determining the number of bonds that the central atom uses, in this particular example of carbon tetrachloride, we use Hong 1, 2, 3, 4, which tells us that carbon can make 4 bonds. And because we have 4 chlorines, we know that there's ultimately 1 bond between each chlorine atom and the carbon atom. And when representing bonds, we're going to use a line, and this line ultimately represents 2 electrons, and we use the octet rule by understanding that essentially each atom has to have a full octet, which is 8, and we're going to use this to represent all the other atoms within all the other electrons within this particular molecule. And upon drawing all the individual electrons, we have to count and make sure that we have 32. And that is essentially your finish. Next, we're going to be talking about exceptions to drawing Lewis structures.
And now it's time for a commercial break!
Yeah, I'm gonna make a structure for my molecule. I'm gonna draw till I can't no more. I'm gonna make a structure for my molecule. I'm gonna draw till I can't no more. I gotta find the central atom, put it on the paper, balance electrons next. Got to add up to find the total, finding all the bonds, draw the structures too. Place all the electrons, you ain't even done now. Can't nobody tell me I'm wrong. Lewis structures all day long. Can't nobody tell me I'm wrong. Feel free to sing along. Finding Lewis structures, but there are exceptions. Hydrogen makes 1 bond, beryllium has 2, 3 is just for boron, nitrogen is special, and elements past period 3, they have expanded octets. Can't nobody tell me I'm wrong. Lewis structures all day long. Can't nobody tell me I'm wrong. Feel free to sing along. I'm gonna make a structure for my molecule. I'm gonna draw till I can't no more. I'm gonna make a structure for my molecule. I'm gonna draw till I can't no more.